Good morning, good afternoon. Today we're going to see the first method of integration that is called substitution rule, and it's exactly the rule or the method associated to the chain rule. Before we study substitution rule, let's remember with two examples the chain rule. So we use the chain rule when we have a composed function and we want to differentiate it. For example, in this case, y or f of x equals to 2x plus 3 elevated to the 4. So what we're going to do is to obtain the derivative of that function by using the expression between parentheses like a u. So we use 4 times u to the 3 times the derivative with respect of x of u. Okay? And what is u? U is 2x plus 3 and 2x plus 3. So the derivative of this will be 4 times 2x plus 3 to cube times the derivative of 2x plus 3, that in this case is 2. So the last thing we do is we multiply 2 times 4, and you have 8 times 2x plus 3 cubed. And that is the derivative of the function using the chain rule. Let's do a second example of the chain rule. The function is y equals to the square root of 3x plus 2. So what will be the derivative of that function? Well, first, we can rewrite the function as 3x plus 2 elevated to the 1/2. So the derivative of the function will be 1/2 times 3x plus 2, that in this case is my u, to the negative 1/2 times the derivative of u, that is 3. So what would that function be? Will be 3/2 of 3x plus 2 elevated to the negative 1/2, or simplifying this, it'll be 3 over 2 square root of 3x plus 2. So by converting this expression or this expression on the parentheses into u, what we are doing is a change in the variable. And that is exactly what we are going to do in the substitution rule. Okay, so if we have the integral of 2 times 1 plus 2x to the 4, we cannot use a simple rule to integrate this. So what we're going to do is a change in the variable or a substitution. What we are going to do is we're going to do u or make u as the expression between parentheses which is elevated. So u is going to be 1 plus 2x. And if we make u 1 plus 2x, we need to obtain du, which is the derivative of u, that in this case is 2 times dx, the differential of u. So what you have to do is just substitute. Instead of 1 plus 2x, I'm going to write u. And instead of 2 times dx, I'm going to use du, because du is 2 times dx. Can you see it? So let's change the variable of my integral. And my integral now will be u to the 4 times du. By using this or by changing this, we can easily integrate u to the 4. The integral of u to the 4 is u to the 5 over 5 plus c. And once you have integrate the function, you can go back to the substitution that you did at the beginning. So as u is 1 plus 2x, I'm going to write 1 plus 2x to the 5 over 5 plus c. And that is the substitution rule. Let's do a second example. We have the integral of x squared times x cubed minus 1 to the 4. As I have already said, the basic rules won't allow you to integrate a product of two functions. So we use again our u. And in this case, our u is going to be this expression, which is elevated to the 4. So u is going to be now x cubed minus 1. and my differential, or the derivative of u, will be 3x squared times dx. So by changing u, x cubed minus 1 by u, we have to obtain in du the other part of the integrand, that in this case is x squared times dx. We almost have x squared times dx, but we have a 3 that is not part of the original integral. So what we do, and it is possible to do, is we divide both sides of the du equation by 3. So in this case, if we divide both sides by 3, we obtain x squared times dx. That is exactly what we have to obtain at the beginning. So let's do our change of variable. This will be the integral of u to the 4 times du over 3. And we can do the integral by first taking out of the integral sign the constant, which is 1/3. 1/3 times the integral of u to the 4 times du, and then integrating u to the 4, which integral is, as you know, u to the 5 over 5 plus c. So what we have is then 1 over 15, u to the 5, I'm going to substitute back u, which is x cubed minus 1 to the 5, plus c, and that is my original function, my indefinite integral, or my antiderivative. Okay, let's solve another exercise. In this case, my u is going to be x squared minus 1. And if we choose u as x squared minus 1, the differential of u will be 2x times dx. And we have just x times dx. So we divide both sides over 2. So we have du over 2 equals to x times dx. And once we obtain the other part of the integrand, we can now substitute. So this will be u to the 7 times du over 2. And that will be 1/2 of the integral of u to the 7 times du, and that will be 1/2 of u to the 8 over 8 plus c. And finally, by substituting back, it will be 1 over 16, because I'm multiplying the two denominators, times u, which is x squared minus 1 to the 8 plus c. So by now you can observe that once you obtain du, once you choose one of the two parts or factors to be u, the other factor will appear on the differentiation of u. And if it does not appear exactly the same, you can divide or multiply by a constant, that du, in order to obtain the other part of the integrand. Another example, a little bit more complex, will be this: the integral of 4x over the square root of 1 plus x squared times dx. So we choose our u as the function which is elevated to another, to an exponent. So in this case, my u is going to be 1 plus x squared. And that expression is elevated to the negative 1/2. If you can rewrite the original expression. So if we choose that as u, du will be the differential of this, that is 2x times dx. So as we have 4x times dx instead of 2, in this case, instead of dividing du over 2, I'm going to multiply du times 2, because if you multiply du times 2, this 2x will be 4x times dx. And by doing so, we obtain the original integrand. So let's change it. This will be 2 du over 1 plus x squared to the 1/2 on the denominator. Or, let me rewrite this. I think it's better if we write this as 2 times u to the negative 1/2 times du, times du. because the 2 of the du is written here. Or if you want, and I think it's clear as that way, I'm going to write u to the negative 1/2 times 2 du. Okay? Constant out of the integral sign, 2, and times the integral of u to the negative 1/2 times du. And the integral of u to the negative 1/2 will be u to the positive 1/2 over 1/2 plus c. So by using the quotient of quotient rule, that will be 4 times the square root of u, which is 1 plus x squared plus c. And that is my indefinite integral, antiderivative, my original function, my primitive function, my love, my everything. And finally, one last exercise before you start in doing the set number 5, the integral of 5x times the cubic root of 1 plus x squared, when we choose u as 1 plus x squared, and du is going to be the differential of this, which is 2x times dx. And this gets a little bit complex because we have to convert 2x into 5x. So how do we do that? Well, we first divide du over 2. And by doing that, we obtain just x. And then we multiply times 5. So 5 times du over 2, it is equals to 5x times dx. So we can rewrite this as the integral of u to the 1/3 times 5/2 of du. And I use 1/3 because, as you can see, the index of the square root is 3. So again, write the constant out of the integral sign. That will be 5/2 of u to the 1/3 times du. And then you just use the basic rule of integration, which is u to the 1/3 plus 1, that will be 4/3 over 4/3 plus c. So 5/2 over 4/3, it will be 15/8 of u to the 4/3, and that will be cubic root of 1 plus x squared to the 4 plus c. So finally, we are obtaining the indefinite integral of each of the functions. So I think at this point of the video, you are questioning if this is possible to verify, and the answer is yes, of course. But in order to verify this type of integrals, we will have to use the opposite of the substitution rule, which is the chain rule. So I'm not going to verify in this video, but we're going to do it on class, okay? So start the set number 5, which is substitution rule on the learning pathway 2. And we can, well, you know that you can ask me in class if you have doubts, and we're going to verify one of the exercises or two of them just after you finish this set. I hope you have found this useful. I see you later.